This is Geometry Chapter 3, Section 6, in which we will consider the ideas of perpendiculars and distance. We put these two things together because they are related. They're closely related. The distance between a line and some point that's not on that line is found by finding the length of a segment perpendicular to the line starting at that point. Okay, picture a line, picture a point not on the line. We could measure from that point to the line in any number of directions. But to be consistent, it was decided that we're going to make the distance be the segment that's perpendicular to that line, so that we're all measuring the same distance each time. And we're guaranteed by postulate 3.6 here, the perpendicular postulate, that if we have a point sitting off of a line somewhere, there's exactly one line that goes through there perpendicular to the given line. That's very similar to the parallel postulate that we had last time, that said if you have a line and you have a point, there's only one line parallel to the original line. This one's saying there's only one line perpendicular to the original line. The basic idea is you don't have two perpendiculars from the same place. Now here is where your book and I have a major issue. They want us to find the distance between some point and some line, and they go through, you can look at what they did in the book if you want to, they go through a lot of heavy algebra. Lots of places to make mistakes. I've got a formula that simplifies all that algebra to something much easier. It looks like a complicated formula, but if you look at what they did in the book in 3.6, I think you'll agree that my formula is a lot simpler than their method. If we have the equation written as ax plus by plus c equals 0, that's to get everything onto one side of the equation so that 0 is all that's left on the right, and we know the coordinates of the point in question, then the distance is the absolute value of, plug the point into the equation, okay, put x0 in for x, put y0 in for y, over the square root of a squared plus b squared. Now don't get this idea confused with Pythagorean theorem and think it would just always be c squared. Those are different a's and b's and c's than Pythagorean theorem would talk about. So don't get hooked into that idea and think, oh, it's always just going to be c squared, because it's not. That's a totally different kind of equation. Just a coincidence that it looks alike. So let's put this equation to work. They're going to give us a line P, that contains points -5, 3, and 4, -6. They want us to find the distance between that line and the point 2, 4. Okay. Well, we have to go through a few steps here. And just remember as you watch and follow along with what we did here, that I have shortened the work the book expects from you. I've found a better way for you. First off, we need to get the equation of line P. Well, we did this in section 3.4. We found equations of lines. We need a slope, so let's calculate a slope. -6 minus 3 over 4 minus -5. -9 over 9 works out to a -1 for our slope. Let's take that to point slope form. I picked the first point this time. So y minus 3 equals -1 times x plus 5. Now remember, we need to get everything to one side of the equation equal to 0. So I need to distribute -1 into both of those, and then I need to move everything over. So we add the x over, and we add the 5 over. Now we've got the equation in the form we want. This is, by the way, called general form. You don't really necessarily need to know that, but just in case anybody ever asks you, there it is. Okay. Now we have general form. Now we have the form we want. Now let's plug it into our formula. We know the values now. A is 1 from here. B is 1 from in front of the y. C is 2. X0 and Y0 are the coordinates of the point. So we're ready to plug and chug now. This was our distance formula that we had on the previous page. Plug in the numbers. 1 times 2 plus 1 times 4 plus 2 over 1 squared plus 1 squared, the square root of that. So we get 8 divided by the square root of 2, which I punched into my calculator and got 5.657. Okay. Now again, I'm going to remind you, I've made your work shorter. You should see everything they want you to go through. It's nasty. Now, because this one is such a tricky thing, I'm going to have you go through, pause and try to do one, and then come back and check it and we'll talk through it again. Okay. First job in this problem is to find the slope. So we found the slope, 2 over 4, which is 1/2. We plug that into point slope form. Distribute the half. Bring everything over to the left to get it equal to 0. So we have -1/2 x plus y minus 1.5 equals 0. Now we plug into our distance formula. -1/2 times 1 from the x of the point plus 1 times 7 minus 1.5. My calculator cleaned that up to be 5. -1/2 squared plus 1 squared is 1.25. 5 divided by the square root of 1.25. My calculator gave me 4.472. Okay. So hopefully the heavy lifting wasn't too bad. Just grinding through the steps. Okay. Another term that we need to know about is the idea of being equidistant. Parallel lines are always equidistant. The distance between them is the same everywhere. Okay, picture some railroad tracks. The train would have a heck of a time if the distance between the tracks changed. I mean, it would have to have some kind of flexible axle to make that work. We can't do that. And the distance between those two parallel lines is the perpendicular distance between them. Okay, we can't just draw a line between the two lines. It has to be perpendicular to both of them for us to find the distance. And this leads to an interesting theorem. If I have a line and I have two other lines, one on either side of it, that's equal distant from it, then the two lines that are equidistant from the middle one are parallel to each other. Kind of a tricky idea to think about. But knowing that they're the same distance away from the same line makes them parallel to each other. Think yard lines on the football field. Okay, the goal line and the 10-yard line are the same distance away from the 5. So the goal and the 10 are parallel to each other. So let's find the distance between parallel lines whose equations are given to us as y equals negative 3x minus 5 and y equals negative 3x plus 6. The answer is not 11. It's not just as simple as subtracting the two things. Darn it. First, we need to turn one of the equations into our general form. I picked the first one. It doesn't really matter which one. I just picked the first one. So now we have an equation in the form we want. On the other equation, I'm going to pick a point. And the y-intercept is a very easy point to work with. We can see it without having to work too hard. So I'm going to use the y-intercept from this being in mx plus b form. Now I've got an equation and I've got a point I can plug into my favorite formula. So 3 times 0 plus 1 times 6 plus 5 all over the square root of 3 squared plus 1 squared. And it's 11 over the square root of 10, which my calculator came up with 3.479. Okay. So the big story for this lesson is our favorite distance formula over here, to be able to find the distance between a point and a line, or the distance between two lines, because we can get a point off of a line. Okay. And if you don't like that formula, you can always use the method that they used in the book. Have fun with that. If you had any questions along the way, hopefully, as always, you wrote those down. You can bring them in with you, and we will see you in class.